Hey Bengals, in this video we are going to be talking about what is work and the definition, how it's measured, as well as how to calculate it. So to start out with, let's talk about the definition of work. Work is defined as a force on an object that causes the object to move, and it is measured in the unit of joules. And there's a couple things that we have to consider when looking at situations and identifying whether or not work has been done. The first thing is, if the object never moves, if your distance is 0, then the whole answer is 0. There's no work being done. The other thing you have to look at is to see whether or not the direction of your force and the direction of your motion are the same. So when you look at a situation, if it says anything about carrying an object, then oftentimes it's not work, because in order to carry something, you lift it in an upward direction, but then your motion is forward, and because of that, those are two different directions. That means there's no work. So as we go through some of the sample problems today, the first step we're going to do is identify the direction of the force as well as the direction of the movement. And then from there, if those are in the same direction, then we will start working out the math. But there's no point to work out the math if those two things are not going in the same direction. So I have a couple samples or examples to show you. Check out these two videos. It's going to talk about factors that may influence how much work is being done. Check it out.
Hey Bengals, this is my example of work. So there's two factors that go into work. It's force applied times the distance that you travel. And we talked briefly about what is the difference between work and no work, but I'm going to talk to you about the difference of when you change force or when you change distance. So here I got a couple examples for you. This is Sarah. Say hi.
Hi.
Okay, so I'm going to lift Sarah up off the ground. My force is in the upward direction, and my distance will be in the upward direction. You ready? Are you ready? Ready? Ugh. Alright. Alright, Bengals, this is example number 2. This is Logan. He's now 5 months old, and he weighs about half as much as she does. So when I lift him, still the same direction, upward direction, is the direction of my force, and my distance. The amount of work done is a whole lot less, because it's about half as much, because he weighs half as much as Sarah does. And the only way that I can get the same amount of work with him is to go twice as far than I do with Sarah. Say hi, Mama.
Okay, so in this next section, I want to give you just a couple more examples of work. In this video clip, we're going to see Albert Pujols hitting a home run, and there's a couple instances where work will be done. So the first instance is that he is doing work on the bat because he's applying a force on the bat, and the bat moves a certain distance. The second instance that work is being done is that when he hits the ball, the bat is doing work on the ball because the bat applies a force and the ball then has distance. It travels. So the amount of force on each one would be the mass multiplied by the distance. So in the case of how much work Albert does, it's the mass of the bat times the distance. And then on the ball, it's the mass of the ball times the distance that it travels. So two other instances when we have work. So the last example I want to show you, and this actually will kind of segue really well into our first sample problem, is of what happens when things don't move, maybe. So in this video clip,
hit well left field. And Alex Gordon smashes into the wall and makes a great catch. Wow.
So in that case, because Gordon Even though he applied a force on the wall, because the wall didn't move, he did no work. So keep in mind that you have to kind of ask yourself a few questions as you get into work calculations. So let's start with our first calculation. You'll need to do this as your action item. So wherever you want to complete your action item on your Wix page, this is your first action item. So in this first problem, it says a forklift moves 34 meters carrying a 1,023 Newton box across the warehouse floor. How much work is done by the forklift? So the motion is 34 meters forward. Since it's carrying, though, it's 1,023 newtons upwards. These are not in the same direction, therefore there is zero work. So something to consider. So we won't even get into the math because it's not in the same direction. There's no work. In this next one, we kind of changed it up a little, and it says a forklift does 1,800 joules of work when it pushes a 120 Newton box across the warehouse floor. How far does it move the box? So we have the 1,800 joules pushing, so it's moving forward, and then the force is also in the forward direction. Since they are in the same direction, we got a check mark. We'll move on to the math. So work in this case is equal to 1,800 joules. The force is 120 newtons, and then the distance is what we're trying to solve for, so I'm going to put a question mark. The formula is work is equal to force times distance. You have 1,800 equals 120 times distance. Now we have to undo the multiplication in order to get distance on the side by itself. So in order to do that, we divide both sides by the 120. Whenever you divide 1,800 divided by 120, you get 15. So in this practice problem, it says, how much work is done by a person who uses a force of 27.5 to move a grocery buggy 12.3 meters. We know it's in the same direction. Work is equal to force times distance. We need to solve for work, so we have the force and the distance. All you have to do then would be set it up and then multiply. So we have 27.5 times 12.3. When you work out the math, you'll kind of see each step that I take, but the end result when you work out the math is 338.2, or excuse me, 25. 338.25. In this last problem, we have 55 joules of work is done to move a rock 25 meters. How much force was applied? So we already know the work is being done, and that implies that the force and the distance have to be in the same direction. We have 55,000 joules of work. We need to solve for force, and then we have 25 meters for distance. So when you set up the problem, it would be 55,000 is equal to force times 25. Then you divide both sides by 25 in order to get to get force on a side by itself. So 55,000 divided by 25, you're going to get 2,200. So in the end, it's 2,200 newtons is the answer.